All right, everyone. Welcome to our next set of notes. This is going to be talking about bone physiology, basically, what makes up bones. We're going to cover this before we go into the names of the bones so that you at least know how bones work. Okay. So, bone tissue is also known as osseous tissue, right? So, it's a type of connective tissue because remember that connective tissue helps to support the body, it helps with storage. Your bones help to support the body, it gives it the structure that it needs to hold the muscles and everything. And it also allows it to store extra minerals, right? That's two of the functions of your skeletal system. So, bone tissue or osseous tissue is going to do both things. Now, you're going to hate this unit because so many things in this particular part is going to have the word osteo in it. Anytime you see that, it's referring to bones. Okay. They're composed of about 40% calcium, 33% collagen, and the rest of it is all the other minerals and things like that. Stuff like phosphates and magnesium and sodiums and stuff like that, all of the extra salts and minerals. Because remember, again, bones help to store extra salts and minerals. Okay. Now, the reason why bones have calcium is because calcium gives bones strength. It makes them strong, it makes them hard, right? So, in case your bones ever get crushed, let's say you're carrying a lot of weight and you're pushing down, like that weight that you're carrying, okay, is pushing down on your bones and compressing it. It's crushing it this way. Calcium is going to prevent your bones from cracking, or at least it's going to try, right? Because sometimes we do dumb things and it'll crack anyway. But it should allow for rigidity. It should allow for strength in that sense. However, calcium is really bad at resisting twisting forces, anything that twists. Okay. That's why you also find collagen. Just like how collagen allows your skin to be stretchy and elastic, right? The collagen in your bones allows it to resist some twisting forces, some torque. So if you're ever like twisting an ankle or twisting a leg in weird directions for who the heck knows what reason, that collagen is going to prevent your bones from shattering, which is probably a good thing. Okay. Now, there are four kinds of cells that are going to be found in bones that are going to help put that calcium and put that collagen in place and put all of those minerals in there for storage. The first one are stem cells. They're called osteoprogenitor cells. And these osteoprogenitor cells are going to be the ones that are going to differentiate into the rest of them, right? These are stem cells. Just like how we have stem cells in the skin, we also have stem cells in our bones. One of these cells that osteoprogenitors can make are called osteoblasts. Osteoblasts are going to produce something called bone matrix. Bone matrix is what we think of when we think of bones. It is the hard, brittle, kind of off white, right? Stuff that comes with bones. If you've ever eaten like a chicken wing and it's like this hard piece of bone, that is what the matrix is, right? Like 90% of the bone, well, I wouldn't say my 90, I'm saying, I don't know, maybe like 70% of the bone is just hard matrix. The hard matrix has all the calcium, it has all of the collagen, right? It has all of the minerals and stuff that are stored inside of it. All of that gets put into the structure of the bone. We call it bone matrix. The process that osteoblasts use in order to create bones is osteogenesis, right? Okay. Osteoblasts also, again, their whole thing is to make the bone matrix. Bone matrix contains calcium and collagen and other minerals. So when you have extra calcium, the osteoblast will store that in the matrix as well. Okay. Then we have osteocytes. Osteocytes are going to help regulate and the mineral content um, of your bones. Okay. Basically, what it's going to do is it's going to kind of ensure that there's enough minerals there to keep the bone the way it is, but they also help to break down old matrix. Okay, so if you ever have an injury or if you're just growing or maybe that part of the bone is old, osteocytes are going to come in. They're going to break that part down. Any mineral content that you still need, they make sure to keep all of that so that you can build more bones with the osteoblasts. Okay. It's going to get super confusing here, you guys, because so far we have osteoprogenitors that are stem cells, osteoblasts that create bone matrix, and osteocytes that are going to regulate bone mineral content. Okay. And it does that by breaking down old matrix so that osteoblasts can rebuild that matrix. Okay. It also has they also have osteoclasts, not to be confused with osteoblasts. Okay, osteoclasts are large cells. They are going to be there to break down bones, especially if you are deprived of it elsewhere. Let's say you are malnourished. Let's say you're not getting enough nutrition and you need more calcium in your muscles or you need more calcium somewhere else. These osteoclasts are going to activate, break down a ton of bone matrix to take that calcium out and shove it somewhere else, right? Osteocytes are just maintenance. Think of it like maintenance, okay? Told you everything is going to be osteo something or other. Now, when we're looking at the structure of bone, we're going to see that, let me put up my laser pointer, right? That it's going to have an outer dense layer of bone we call compact bone, and then an inner layer of kind of holy like bone. We call it spongy bone. Okay. Again, compact bone, super dense. Spongy bone, full of holes. It's like a sponge, literally like a kitchen sponge. Okay. Compact bone, we need it to protect against forces that will push down basically along the longitudinal direction, right? So if this is a bone, let's pretend this is a bone. The force that compact bone is going to prevent is the force that pushes from the top. It pushes down so that the force goes along the bone. It goes along the bone. Your spongy bone is great because all the little holes and stuff, it creates a kind of a shock absorber at the ends of your bones, and it's going to protect you against the forces that are going to push away in many different directions, which is why spongy bone is going to be found near the ends of the bones where your joints are. Your joints don't always stay in one place, right? They can move in all these different directions. So if an injury occurs at the joint or near the end of the bone, spongy bone is going to be there to protect your bone from shattering. Compact bone will help it when the force is coming straight down the bone. Okay. Now, with layers of the bone, you've got your compact bone, inside is spongy bone. On the outside of your compact bone, basically covering the entire bone on the outside, is a layer of connective tissue we call the periosteum. Periosteum is important because it's going to hold blood vessels and nerves that are needed by the bone. Bone can or has living tissue in it. It's not completely dead. The matrix doesn't contain any living tissue, but everything else, the cells that make the matrix, right? The cells that break down the matrix, the cells that do all these things, those things are going to need a lot of nutrients, a lot of blood vessels. Your bones can feel pain. This is why it hurt if you grew really fast during puberty, right? There are nerves there that are telling you when it's painful. Okay. Spongy bone is lined by a layer of connective tissue called the endosteum. So imagine outside you have the periosteum, then you've got compact bone, and then you have endosteum. The endosteum it kind of like covers the entire inside of your compact bone. So it's going to protect what's inside the bone, which is going to be bone marrow. It's really hard to explain. It kind of coats all of the holes on the inside. right? So there isn't a single part of the surface of spongy bone that isn't covered by endosteum. Now, speaking of bone marrow, because bone marrow is going to be found in the side of bone, right? It's being protected by this endosteum, it's being protected by spongy bone, right? There's two kinds of bone marrow. We have red bone marrow, that's marrow. Marrow, that's where all of your blood stem cells are going to be found. All your red blood cells, all your white blood cells, all your platelets, they come from here. Okay. Red bone marrow is going to be found in your spongy bone. Then you have yellow bone marrow. Yellow bone marrow is mostly fatty tissue, and it's going to contain stem cells that, believe it or not, become cartilage that goes like that are found at the ends of your bones, at your nose and stuff like that. It produces fat and it produces more bone cells, right? It is located in an area called the medullary canal that is inside of long bones. So let's take a look at this picture. Okay. You have a periosteum on the outside of the bone. It's holding all of these blood vessels in place. These blood vessels enter the bone through that compact bone around the outside. Okay. And that compact bone surrounds the spongy bone. Inside the spongy bone is going to be your endosteum. The endosteum is going to be there to help it protect the bone marrow. In the spongy side, you have red bone marrow, and in the middle of the long part of a long bone, so something like your thigh bone, right? It has a really long, hollow center. Inside is yellow bone marrow. Okay. If you've ever seen like big pieces of bone that people grill for the bone marrow, that is going to be a leg bone from like a cow or something. That's why it's so big. Okay. And in the middle, where this yellow bone marrow is found, is called the medullary canal. So let's look closer at compact bone. Compact bone, it's solid, but it's not like a complete, just like dense, solid mass. I mean, it is and it isn't, right? It's not completely solid. It has holes in it still. It's just not as much as spongy bone. Okay. And there's a bunch of actual structures inside. Now, compact bone is actually made of these circular structures we call osteons. Okay. Inside of the osteons are those osteocytes, bone cells called osteocytes. Hopefully you guys remember that, right? But there are round structures called osteons. They kind of follow the entire part, like the entire structure of compact bone. And in the middle are going to be blood vessels. Okay. So you're going to have to imagine if it was round and I cut a wedge from it. Okay. Along the inside, there's a bunch of these circular kind of columns of bone matrix called osteons. Osteons contain osteocytes. The osteocytes, again, help regulate mineral content and stuff, right? And then in the middle of that osteon is a canal for blood vessels. Okay. The osteocytes are connected by tiny little passageways called canaliculi. These canaliculi allow the osteocytes to share nutrients and to communicate with each other. Okay. The layers of the osteon are going to be called lamellae. Okay. The layers, each ring is called a lamellae. Inside the lamellae or between the lamellae are going to be your osteocytes. Connecting each osteocyte to each other is a canaliculi. I know. Now, the blood vessels that are in the middle, there's a hole through the middle of every single osteon. Okay? That hole is called a Haversian canal. A Haversian canal is going to contain your blood vessels. These blood vessels go the entire length, basically, of the bone so that you can have osmosis and diffusion to feed the osteocytes that are found in these osteons. and they are connected to each other. So each of these Haversian canals containing blood vessels is connected to the next Haversian canal containing blood vessels through these things called Volkmann's canals, right? So this way, again, they are connected, they can share blood, they can share nutrients with all each other. Like everything within the bone is super connected. Okay. Now, bone begins to grow at about 6 weeks after fertilization, so pretty fast. Um, they will continue to grow until we're somewhere between 17 to 25 years of age. So the majority of you guys aren't going to grow any taller at this point. Okay, some of you might grow another inch or two, but for the most part, this is where you're at, unless you hit puberty super, super late. At about 17 to 25 years of age, once you have stopped growing, your bones don't stop doing stuff. Okay. They are dynamic, meaning they are constantly breaking down and reforming and breaking down and reforming, basically until you're old, right? They're not going to grow any longer. You're not going to grow any taller, but they will repair themselves. They will do things. It is living tissue, right? They can get thicker, they can get thinner, denser, less dense, all of these things. They just will not grow any longer. So you don't get any taller. Okay. Now, there's two ways that bones develop. The first process is called endochondral ossification. Endo meaning inside, chondro meaning cartilage. So basically, what happens is as the bone or as the body is developing, the body first creates a little outline with cartilage. Okay, cartilage is another type of connective tissue. It's the stuff in your nose, it's the stuff in your ear, right? It's kind of like that flexible but gives you structure. Okay, so your body forms a structure out of cartilage, and then slowly that cartilage is going to be replaced by bone. Um, so think of it like a blueprint, and then we build bone using that blueprint. Oh, sorry. I probably should have pressed that earlier. But right? The word ossification means to turn to bone. So endochondral ossification. The cartilage turns into bone from the inside. We have a structure made of cartilage. It fills with bone afterwards, and then it becomes a bone. That's endochondral ossification. It occurs in most bones in the body, especially long bones. Long bones are going to be made by endochondral ossification. Okay. The cartilage that starts off this process is a special kind of cartilage called hyaline cartilage. It is kind of blue-white in color, and it's going to be found later on in your joints as well as in your respiratory tract. It's the stuff that prevents your throat from collapsing, basically. Okay. This cartilage, again, contains living cells we called chondrocytes. Chondro, anytime you see the word chondro, it means cartilage. And these cells are going to create the cartilage. And over time, what's going to happen is these structures become kind of imbued with calcium, right? The body is going to take calcium and shove it into these structures made of cartilage, and the cartilage is going to harden, and that's what forms the bone from endochondral ossification. Okay. This hardening of the bone stops blood and nutrients from getting to the chondrocytes, which kills them. And that is going to trigger the death of these chondrocytes, will trigger nearby blood vessels to start to grow into it. Because now that you can no longer have osmosis and diffusion, you have to get stuff in there somehow. So these blood vessels start to grow into the cartilage before it hardens. And these blood vessels are going to bring in stem cells, okay? So that these stem cells can replace the chondrocytes that used to be there. The osteoprogenitor cells will then set up what are called primary ossification centers, and that allows osteoblasts to form. Okay? Osteoblasts will then do what they do, which is build the bone matrix, and the growth of bone starts from these primary ossification center and moves outwards towards the ends of the bones. Okay? Doing this creates something called an epiphyseal plate. This is where the ossification centers are found. Okay, so any growth occurs from right here at the epiphyseal plates. It's going to grow this way. Okay, they're also known as growth plates. It's a lot. Now, as the structure continues to ossify, right, turn into bones, secondary ossification centers are going to start to form near the ends of the bones, grow towards the primary centers. They'll kind of meet in the middle, okay? And that's why the epiphyseal plate is where it is, right? You get two bones or two bone growths coming out or coming towards, right, each other, which creates that epiphyseal plate. Okay, I promise we'll have time for this. Okay, so let's take a look at this again. You start off with hyaline cartilage. It is made by those chondrocytes. They form these little bone structures made of this blue-white cartilage called hyaline cartilage. Okay. Calcium gets deposited into the cartilage, which kills a lot of the chondrocytes. And that causes these blood vessels to grow into the calcified areas. As this is happening, the blood vessels bring in osteoprogenitor cells. The progenitor cells create a primary ossification center and start making osteoblasts. Osteoblasts start building bone matrix. As it builds bone matrix and the bone matrix starts moving towards the ends of the bones from here in the middle, the blood vessels bring in more osteoprogenitor cells at the ends. This creates secondary centers. The secondary centers start growing towards the middle. And as they grow, they are going to form these growth plates, these epiphyseal plates, right? As the two parts sandwich one another. And any growth that happens to the bone after this is going to occur from the epiphyseal plates. Okay? That was just endochondral ossification. Then you have intramembranous ossification. Okay? Intramembranous ossification occurs with hormones. Then these hormones are going to cause the cells from some of the connective tissues that are just found within the embryo to develop into osteoblasts. It says, hey, weird stem cells, you're going to become osteoblasts. These osteoblasts are then going to start to build spongy bone into the shape of bone, whatever that shape may be. And over time, the outer layer is going to get replaced by compact bone so that it has a outer protective layer. A lot of your flat bones are going to be made this way. Things like your sternum, right? Things like your skull, things like your, I'm not sure if your patella is made this way. I'm going to be honest. I think it is, but I could be wrong, right? Whoop. I guess I don't have a picture for this one. I guess I forgot to put one in, but that's okay. So just imagine a bone being made out of spongy bone, and then the sort of compact bone gets added to the outside. It's flat. I don't know. Right? So now there's many disorders that can affect bone growth. Achondroplasia is a disorder that affects ossification of cartilage and bones. Basically, it prevents long bones from becoming long, right? This is why people who have achondroplasia are going to have very short limbs, right? The long bones in the bodies are going to be affected because it affects endochondral ossification. Because achondroplasia, you can't ossify your bones, or at least not to the degree that you need to. And ossification, again, happens in long bones. Long bones give us height, okay? Without it, they have regular size heads. They have regular size like ribs and rib cages. It's just their arms and legs are affected by the lack of ossification. Okay, so these are features of achondroplasia. that could occur due to, oopsie, sorry, having low ossification. The other thing is osteogenesis imperfecta or brittle bone disease. It's a genetic disorder that is going to cause very, very brittle bones, being because the body is not able to make bones very well. Okay. There's a lot of symptoms to osteogenesis imperfecta. But one of the most prevalent signs that you have it is what's called the blue sclera. Like the white part of the eye, instead of being white, is blue, right? Here's an example of eyes of a child with osteogenesis imperfecta, and here is an example of their hand. Notice the curvature in the bones. These people that have osteogenesis imperfecta or brittle bone disease make bones that are kind of not very strong, okay? The calcium in them, for whatever reason, it's just not very good. It doesn't create the bones very well, okay? I know that's a lot. We will spend time on this. Don't worry about it too much. But that's the end of the notes. Bye.